We start chapter 3 today, and I'll be honest, chapter 3, well, every day is going to be a little bit of a challenge. Um, we start out with parabolas and quadratic functions. We'll be moving in later to other types of nonlinear functions. Um, so, inverse functions. We'll be talking about radical functions, rational functions. It's going to be a lot of work. Hopefully we'll be able to make a lot of connections, a lot of opportunities to use your graphing calculator. But it's going to be a challenge, and so make sure that you are well prepared for each lesson each day. So today we got 3 learning targets. The first 2 hopefully are going to be kind of the easy thing of the chapter. You're just going to be graphing parabolas by using a couple different methods. 1, the axis of symmetry, and then 2, using the vertex form. And then the other thing we'll be doing in this lesson is solving quadratic applications using a graph. So we've got a lot going on here. So let's get to it. A number of things that you're going to need to know. Polynomial function. Well, what is a polynomial function? Well, simply put, we could say it's kind of like f of x, like an example. Polynomial just means many, or poly means many. So we could think of, like 4x to the 4th plus 3x to the 3rd minus 2x squared plus 4x minus 6. Okay, this would be an example of a polynomial. You can see all the parts. We got the coefficients. Coefficients just have to be real numbers. And then we've got the leading, I guess this is the leading coefficient. We've got the degree, which is the exponent of the leading term here. And so this is a 4th degree polynomial. And so that's a polynomial. We'll be doing a lot of stuff with polynomials throughout this unit. Specifically, today we're going to be working with polynomials of the 2nd degree, meaning they're quadratics. So it'd be kind of like 2x squared plus 4x minus 6. Okay, the largest exponent will be 2. And when we graph that, we're going to get something called a parabola. And of course, you likely know what a parabola is. So we'll just draw a quick little one right here. Okay, so parabola looks like that, kind of like the U, or I guess if it's upside down. Some of the key parabola parts that you're going to need to know. Okay, parabolas are symmetric. Okay, and so the line that makes them symmetric is called the axis of symmetry. And that is usually referred to as like an equation. It'd be x equals something. So in this case, it might be x equals 2 or x equals 3. We also have the vertex, the place where it changes direction. It's called the vertex. And that's going to be an extremely important point as we start to graph. All right, so that's kind of parabola and its 2 major parts there. Let's see, vertex form is something that you're going to need to know, and we actually saw this in the previous chapter. It's just y equals a, which is the stretch factor, times x minus h, that shifts it left or right, squared, plus k, that shifts it up or down. And remember that the h, again, was opposite of the sign, so if it was positive, it went left. If it was negative, it went right. And the k moved it up and down, but if it was positive, it went up. If it was negative, it went down. All right, well, we got 2 methods for graphing here. We have the axis of symmetry method, which means step number 1, find the axis of symmetry. Okay, and you're going to do that by using the little equation x equals negative b over 2a. Remember that up here it's x equals. So the way that we get that is to take the b value, whatever is here, do the opposite and then divide by 2a. And then step number 2, okay, we'll use whatever x equals to find the vertex. We know that the x value of the vertex is going to be on the axis of symmetry, so we have the x value for the vertex. So we just need to plug that x value in, we'll find y, and then we'll have the full coordinate for the vertex. And then step 3, okay, either use the y-intercept, to plot a second and third point. Okay, so if we have the y-axis, okay, because we know it's symmetric, we'll have another point on the other side, so that's usually enough. Okay, or we could pretend like this is the origin, just use the a value, which both of these things are things that we used in chapter 2. So the vertex form, just to go back to that for a second, if you have been given a regular quadratic trinomial, okay, we can complete the square to get back to vertex form. So you recognize this is kind of like completing the square, x minus h squared. So if we complete the square, we can turn something into vertex form and graph it pretty easily, which is why that shows up today. All right, and then the projectile motion formula. It's an important one to just kind of have memorized. But we got h, the height, is equal to negative 16 t squared, plus, where t stands for time in seconds, the initial velocity times the number of seconds plus the starting height. So these sub-zeros just mean initial velocity, initial starting height. All right, we'll be using that for some of the problem solving later on. Okay, let's get to the first couple examples here, which are going to go by hopefully pretty easy. So, graph using the axis of symmetry. So, step number 1 is to go ahead and find the axis of symmetry. So x equals negative b divided by 2 times a, which is 2. So you've got negative 4 over 4, which is negative 1. So I'll just go ahead and graph my line x equals negative 1 right there. All right, so there's my axis of symmetry. I'm going to find the y value when x equals negative 1. And I'm going to do that by just plugging in negative 1 into my original formula here. And I'm going to get 2 minus 4 plus 5, which is going to be positive 3. All right, so that means my vertex is right here. I know that my y-intercept, the y value when x equals 0, is going to be 5. That seems to be the easiest thing to do. I've got a symmetric point over there, and that's just about enough to draw a fairly accurate graph. If I wanted to, I could just pretend like that was the origin and graph y equals 2x squared. When x equals 1, y equals 2, so over 1 up 2, you can see that it winds up being exactly the same. All right, moving on. Here we've got another trinomial quadratic, and so we're going to use the vertex method this time. So here's the thing. I'm going to just turn this into y equals 3x squared minus 2x plus 1. I'm going to be moving stuff around. I think the y is going to be a little easier to deal with than the f of x. So just like how we completed the square to solve quadratics, let's kind of do the same process. I'm going to push the 1 over to the other side, get it out of the way, so subtract 1. And then I have 3x squared minus 2x. If I'm going to complete the square, I have to have an a value of 1. So I'm going to factor out the 3, which is nice for this part, except, well, I'm left with a little bit of an awkward negative 2/3 x in the middle. Okay, well, at this point, I'm free to complete the square. So I've got this x squared minus 2/3 x. I want to take half of this and square it. Half of 2/3 would be 1/3. 1/3 squared would be 1/9. So I add 1/9 to it. But remember, what did I actually add to the right? Well, that'd be 3 times 1/9 would be 3/9. or 1/3. So if I added 1/3 to the right, I would have to add 1/3 to the left. So we'll finish writing this out. 2/3 x plus 1/9. All right, at this point, I'm going to go ahead and simplify the stuff on the left here. That's going to turn into y minus 2/3. On the right, I'm going to go ahead and factor this trinomial. Remember, it's just going to be half of this guy. So even when it's weird, it's okay. Just take half of that. Half of 2/3 is 1/3. And I got that squared. All right, well, I guess I can just finish it off here. I'll add the 2/3 to both sides. So plus 2/3. And now I've got it into my nice vertex form. So I'm going to say, all right, I want to go 1/3 to the right and then up 2/3. So it doesn't look real pretty here, but we're doing okay. And then I have an a value of 3. Well, because I'm a little bit off here, well, let's just use all the things that I can. I know that the y-intercept is 1, so I'm going to use that to help me. But this is not super great for graphing the rest of the parabola. So I am going to use kind of this idea of y equals 3x squared, pretending like this is the origin. So if I went over 1, 1 squared is 1, 1 times 3 is 3. So up 1, 2, 3. So I'm right about there. And then I would have a symmetric point, which would put me right about here. And I think that's probably enough for me to graph as best I can. And there it is. So that's using the vertex method, completing the square. Okay, let's get into some problem solving. Here, of course, we need to utilize that projectile motion formula. So let's write that out. That's a good place to start. The height is going to be equal to negative 16t squared plus the initial velocity, which is 80 feet per second. So 80t, and plus the initial height, which is 100. All right, so this is what I'm working with to start. That's my formula. It says after how many seconds, so there's basically 3 types of questions that we could ask here. All of them utilizing some form of quadratic. So after how many seconds does the projectile reach its maximum height? So remember, okay, this is negative, so it's going to be concave down. It's going to look something like this. Okay, the maximum, if my y value is kind of my h value, my height, okay, my maximum value is going to be, well, the vertex. And so all this is asking me is, well, what is the t value? What is the time when it reaches its maximum height? What is the x, essentially, of my vertex? And then what is the maximum height? Well, that'd be kind of like the y, or the h. And so really this is no different than the first steps of graphing using the axis of symmetry method. So we'll say for part A, we'll just say t equals negative b divided by 2 times a, and that's going to wind up giving us 2.5. So after 2.5 seconds, it's going to reach its maximum height. What will that maximum height be? Well, the maximum height will just simply be the h value when t equals 2.5. So negative 16 times 2.5 squared plus 80 times 2.5 plus 100. And we put this together. I'm sure you can put it into your calculator as well as I can. We would wind up with exactly 200. And of course, we're working with feet, so 200 feet. So that's one type of problem-solving question that we could give you here, and that's using the axis of symmetry stuff. Part B, for what interval of time is the height, so that's this part, the kind of the y, greater than, so we're going to be using an inequality, 160 feet. Well, 160 feet is going to stand for the height, and I want to know when this is greater than, when my stuff is greater than 160. And so I just leave the formula as it is, negative 16t squared plus 80t plus 100. If it's quadratic, so I need to make it equal to 0. So I'm going to subtract 160 from both sides. So I got negative 60 now down here. And, well, I think we could probably simplify this a little bit for ourselves. If I divide everything out by negative 4, I'm going to get positive 4t squared minus 20t, and then plus 15. Okay, and at this point, we're actually just going to use the quadratic formula. So if we set up the quadratic formula, again, to save some space and time, I'm just going to go ahead and skip to the end here. But t is going to wind up equaling, if it were an equation, 0.92 and 4.08 seconds. So what does that mean within the context of our problem? Well, again, here's what's going on. We've got a parabola. It's looking something like this. Okay, and I want to know when it's greater than 160 feet. Okay, so if I kind of drew this line here, it's going to be greater than. Well, it would be equal to 160 here at one point, and then it continues to go up, and then it's coming down and be equal to 160 right here. So it's in between these two values, okay? So this right here would be 0.92, and then this right here would be 4.08. Okay, in between these two things, it's going to be higher than 160 feet. And so we can go ahead and say the time interval where it's in between these two, or where it's greater than 160 feet, is 0.92 seconds and 4.08. All right, so that's another way of going ahead and giving it to you. Let's try the third type of question. After how many seconds will the ball hit the ground? Well, what is the height when the ball hits the ground? The height is 0. And so the way I set up the equation this time is, let's just say h equals 0 equals negative 16t squared plus 80t plus 100. Okay, and we could try to factor it, but I have a good feeling that the quadratic formula is the way to go. And again, we've talked about that, so I'll save us some time and space, and we'll just go ahead and say that t is going to be equal to 6.04, and another possibility is negative 1.035. Okay. However, can I have negative 1.035 seconds? No. So that is an extraneous solution, and 6.04 seconds is all we've got. All right, now this next one utilizes your calculator quite a bit. And so, it really would have just been better for you to take this in class. But I'll just kind of write some of the steps out. So when it says prepare a scatter diagram, okay, we're thinking of this like X, not like Y. Well, I gotta go. Maybe I'll post a different video for this one. Anyhow, here's your learning target.